All right. First of all, I want to just say I'm not good at this. I'm not set up to do any of this. I'm a researcher. That's what I want to do. But I need to get this research out there because it's kind of it's a little over the top. It's not something that anybody is accepting yet. However, as you can see, I have DNA reports. I have CAT scans. I have expert testimony, agreement that these are anatomical specimens and they fully understand the anatomy. I have 7 CAT scans. There's 3 of these DNA tests have been done. They're all positive. So I need it to be looked at to somebody to either say no, these things are all wrong, or yes, this is something that needs to be looked into. I have gone as far as I can go. I've recreated the process, actually. I've done everything that they asked me to do. I presented this to Yale long ago, and they dismissed it. I understand that. It's a little spectacular, and they have a lot of other things to do, but they told me that the only way they could ever think about this is for me to do these things that I did, and they still won't look at it, so I'm sort of stuck in the middle here. Anyway, I need somebody to look at this, and this is the DNA report. It's quite detailed, and it went down through all how it was done and all the different samples, and all the very, very detailed analysis. And it came down and it showed all the information about the graphs and everything. Now, and these are all done, and they matched it to some major database that has all of the creatures ever known to exist as far as they know of, and it matched 100% to human DNA. Now, I'm going to show you the items, and they are not accepted again as actual fossils, because these are not just bones. These are actual pieces of creatures. I know it sounds crazy, but I have figured out the process. I do chemistry, and I'll show you. I'm going to show you a little of my chemistry background, just some papers and things, quickly, so that I can establish some kind of credibility, because I have very little. And anyway, this all was done, and it's very, very detailed. And anyway, that's. All I want to do is have it examined by someone that can give me, and I want somebody extremely critical. Scrutiny, I want as much scrutiny as I can get, because I think I have proved my case pretty solid. And I'm going to show you the chemistry, I'm going to show you the specimens, and I'm going to talk a little more about this in a second. All right, I'm just showing you this so you understand. I do understand chemistry. I've been doing this all my life. And I come from the semiconductor industry, and I understand crystals and all of that stuff, electronic movements, and I was a field engineer for quite some time. Anyway, I do understand this stuff. I have lots and lots and lots of evidence to back up the fact that I'm fairly well schooled at this. Now, I discovered some processes that previously had been overlooked, and the reason is they didn't take into effect the electrical currents that are in the earth that are generated when you're in continuously wet micro-platy polar silicates. And that is exactly what we have here. It's some of the finest mud and clays. And they create this as the water passes through the soils. And in continuously wet soils, there's a continuous spontaneous potential, and this is fully understood. You can look it up. It's called, I think they're called spontaneous earth potentials. You'll see it, and they are the reason that these creatures that are buried in muds, in this fine particulate, the electricity in the soil actually plates the creature, and the reason is that the skin of creatures and humans, and in this case we're dealing with humans, contains 50 times the amount of silicon that is in the rest of the body. And that is a protective agent. It protects you from the environment. Now, in the organic world, it's sort of suspended, and it is a protection. Now, as you die, and it has no more suspension within the matrix of the body, it becomes invaded by oxygen. So you end up with SiO2, silicon dioxide. And that is driven in, or is sucked out, however you want. I'm sure it's driven in because you're driving molecules into it. So virtually it's rusting of the silicon. And at that point, it begins to plate, just like you would plate a cheap ring. So the silicon begins to turn into a crystal, SiO2, and it begins to plate over itself just like shingles over the top of a roof of a house. And they continue completely encasing the creature in this coating of these crystals, and they become almost impervious to anything. Eventually, the smallest molecules only can wiggle through these little plates. And the smallest molecule that is the most reactive is OH minus. And that you have one oxygen, you have one hydrogen, and it's got ionization. It's got a negative, yeah, it's negative, I believe. Anyway, it's got a polarity to it that is extremely reactive. And that wants to work with other molecules, and it specifically attacks bone. Well, it attacks all kinds of stuff, but bone is destroyed by it, and bone becomes indistinguishable in its calcium look because the calcium has been transformed. And bone is calcium and phosphorus. Anyway, those materials are highly reactive to the OH minus, and there's other invasive chemicals that come through there and change it. And they turn into like a yellowish looking crystals, and they do all kinds of things, but they become indistinguishable as bone. They can be seen in the CAT scans as a that they're in there, and so forth. But anyway, this is all pretty well. I think I understand it pretty well. It just needs to be examined, and maybe I'm wrong, but I need to have something examined. I do have the CAT scans, I have the DNA, I have the expert analysis that they looked at, and there's absolutely, these are anatomical specimens, there's no question about it. They saw all they needed to see and made that determination. So anyway, I need to have somebody, can authorize it, can check this and verify it or debunk it. I mean, I can go either way as long as they can come up with some evidence that means that all these things are wrong, and I don't know how they're going to do that, but I want to show you the specimens and we'll go from there. All right, the first thing I want to say is a special thank you to Jesse Garant and Associates. They're in Michigan, and they're up in Canada. They did the CAT scans, and they did them for no charge. In the interest of science, they knew what was here, and they decided they were going to help out. Now, this is an item that was sent for DNA testing. This is a lung, and this is the investment of the lung, and that's the upper investment of the lung, and that right there is the airway that comes inside. This is the patterning of the lung, and I'm going to show you all this. This material is fascia, or I mean, they have another word for it. I think it might be pleura or something like that on a lung. But what it is a coating, and this coating is the preservative agent. These preserve in mud just like they do in the wet environment of the body. They're supposed to be a barrier. That's what their whole function is. And all this keratinous material in here, this fibrous material, and I'm going to show you what it's like in a human body, in a living human body. It's almost the same as it is when they're dead. And this is the same thing. This is, hold on a second. This is the type of preservation we have here. It's absolutely phenomenal that these things are preserved almost like they're living flesh. And the inside of here, you can see the fibers that are the bands of muscle, and you can see the elastins and everything. They're all in here. And this is fascia. This is fascia. It's a same stuff you have in our bodies. And you can see right there, that's a fascial lap. flap they call it. And that thing there invests the fascia into the rest of the fascia. The fascia now has got a complete system that coats the body. They realize that it's not just something that is like fluff in there. This is a major factor, fascia. And then anyway, that's coming out and I noticed it in my stuff, and I've been talking with people over in Germany about it. They realize that they're doing some work on fascia. Anyway, very interesting stuff, and it's because of this protection of the mud. And it's always been thought of that mud won't protect. Now, and wet environments won't protect. Now, I can agree with that if it's a porous environment where oxygen can get down there, and the moisture, the oxygen, you're done. I agree with that. But when something is in this this particular area, the fine platypolar silicates, and I've done pretty serious analysis on this, and that's what it is, and that's what coats them, and the electricity in the earth protects them, forces that coating on quickly, and I have no idea how old these things are, because I really don't have the money to do all this stuff. I've done a lot of stuff that I just can't afford to do anymore, but I have everything that I think I need. I just can't go any further. I'd like to find out how old they are, and everything about them. And that's what I've been asking for. That's all I'm asking for. Somebody take a look. If they think it's just silly stuff, I'll throw them back in the woods. But you'd have to prove that to me, and I think I proved that it's not. So that's the case. I need someone to come along and look at this. And I have some other stuff that's just phenomenal. When I took these out of the ground, they literally bled. And I'm not kidding you. I'm going to show you. So it's bizarre, but it's true. And I understand why. Because I found out that the whole idea of this is pH. It's all about pH. And when something is in certain pH, is extremely acidic and then caustic and acidic and so forth, back and forth. There's things called chelation, where metals are stored and protected, and then as they hit with acids, they come out. This particular area was a deep, deep rift valley. And it's been said by a paper in Yale that this is a doorway into the earth, this exact spot. And it's got horse graben faulting, which is where the lowest areas of the earth lift up. You can see here, this is tectonite. Ultramafic. This is ultramafic. I have tectonites here that are the, LNS tectonites. But ultramafics, this is as deep as you go. This is where everything gets flat. They flatten out and they turn molten. I have other stuff that was higher up. I have bones here. Do you see these bones? Now that's an articulated bone. That's not a stripped down bone like you find that they usually look in the normal fossils. This still has the cartilage. It has the enthesis points. It has all the Sharpie fibers. It's a complete anatomical model of a living bone, not a dead fossilized bone. But you notice in here you don't see the bone. Well, that reason is because the moisture and the invading molecules and ions turn it into different materials than bone. However, it still has a lot of organics in there, and this would easily test organically, as this did, as a couple other items. That one back there, and there was another one, I forget what it was. It was some skin. Anyway, it's bizarre, but it's true. And some of them are small, as is like normal human beings, and some of them are quite large. So I need to have it looked at, that's all. I'll show you the CAT scan in a second. I don't know how well this is going to play out here. This is from right off the internet. It's called What is Fascia? And that right there, that little flap, is a fascial investment. And all these little fibrous keratinous materials are what we're finding in the fascia of the mud fossils that we have. I don't know if that'll show up well. Anyway, that is what is fascia, and that is what I just showed you here. This is the same material, and there's a latch right here. It has the actual fascial latch. There it is right there. I don't know if you can see that. Like I say, this is not good lighting, and it's not a lot of things, but it is what it is. Alright? Alright, I mentioned that some of this stuff came out of the ground. It literally bled, and that is true. This is exactly what came out, and I'll show you the item that it came out of. It was a lung. And it had another lung that was completely tested and totally 100% human. And that's this one here. It was DNA tested, 100% human. This one was, the fascia was missing, but you can see the lobes of the lung underneath, and this is just bled, literally like blood coming out of it. That's what I just showed you. This one had vein and arteries in here. And that black on the top is what they call a silhouette, a bone silhouette, the black from the ferritins in the bone, and that's exactly what your finger looks like underneath. It's all human remains, and they're, and as you can see, they're very, very large. Some of them are normal, like this is a normal human lung, and other ones, I don't think this is too exceptionally large, but this right here is the tip of a human finger, and it's been tested and CAT scan and DNA, and it is 100% human, and it is quite large. As you can see, it's about 7 inches long. It's about 6 or 7 inches wide, so it's from a pretty good sized guy, not your average citizen. This was earlier when this was just taken out of the ground. It really had almost exactly the same color as the meat. It's darkened up as it's been sitting around a few years. Alright, this is one of the CAT scans, and this is the fingertip. That is one fingertip, and I believe it's a left thumb. I believe it's just like that. And that's the fingernail bed. It's clear in other shots as well, and that's that little lump that's in the back of your finger. If you follow all the architecture, you'll see the skin goes around this way, the fingernail bed is here. Under here is what's called an apical tuft. In the CAT scan, all through here, you see all these little holes and things. It's what's called areolar tissue. It's somewhat degraded, but this is pretty fresh. This thing is not very, it's not deteriorated much at all. It's only the skin really is missing, and the fingernail, and a little bit of the flesh here and there. But anyway, it's got all the details. You can see inside the soft bone, the hard bone, everything. Let me see if I can find another shot here. Well, this here inside, you can see all these features inside on a CAT scan. That's the apical tuft, and that's in there. Here's another shot showing the outline of the fingernail. Underneath there is the areolar tissue. This is the bottom, and there's pads on the bottom of your thumb. If you start feeling around, you'll feel high and low spots, and those are all here too. And that's here. That's the apical tuft right here on the end. It has all these circular investments in a very knobby thing. And then these are the pads of your fingertip. They're all the same. And it was all kinds of stuff. This shows the areolar tissue. See the bone pattern inside there? And there's a lot of other shots here. They did a fabulous job with these CAT scans, with Jesse Garant and so forth. They're active. See, there's the bone halo on the outside, and there's the soft bone on the inside. It's all here. And you can see the area. See, this is boom, boom. See these little holes? Those are the blood investments that go around the outside of your finger, and they're called areolar tissue. Areolar means holes. There's holes all through here, and that is what feeds the basement layers with blood and all that business. Anyway, it's pretty conclusive. So I just need somebody to take a look at it. All right, this is the palm of a hand that went with the finger that was CAT scanned, and it was also DNA tested and proven to be human. And this is the palm that goes with that finger. Now, if you notice down here, look really carefully at the structure of that. It's like somebody almost painted it on there and gooped it on there. This whole area here is the palm of the hand, and I believe it's the left palm, and it's there. Now look, watch right down here. If you bend your hand back, you end up with a tendon identical to this. Alright, and that is different than the rest of the hand. Now if you notice down here, you're going to see that same silicon dioxide that I've talked about. That is the preservative agent. That's where the thumb ran off that side, and these were the fingers. And we found a bunch of the fingers that go with it, and some of them been CAT scanned and DNA tested, and they're human. And there's one that actually looks like it has a fingernail still on it, but the fingernail's gone, but you can see where it was. Anyway, it's pretty interesting.